Good afternoon, students.
Good afternoon, sir.
All right, today, just because of time, we would take another phase of simple pendulum. This time around, using a spring balance. Using what?
A spring balance.
Now, because the spring balance isn't available, we have to get a spiral spring. We have to get what?
A
Spiral spring. Now, this spiral spring also works on the same tenacity as that of the pendulum bulb we did last time. Okay? Now, this experiment is all about placing different masses. Placing different what? Masses on this mass hanger. Different masses on this mass hanger. Now, we have different masses on this mass hanger. Now, this mass hanger just has the ability to vibrate. To what? Vibrate at different time intervals. Now, for example, we have actually done it. We have finished it, but this is just a schedule of how we were able to do that. Now, having known the type of thing we are about to do, this mass hanger here, when dragged a little bit down, it will vibrate. You see it oscillating or vibrating. Yeah? Now, just as we did, we were able to get these readings from this oscillating mass here. When we hung the 50-gram mass, we vibrated or oscillated this mass hanger 20 times. It oscillates at 20 times, that is 20 oscillation. Now, when we did that with our stopwatch, which is with him, now we had 5.8 seconds on our stopwatch. That's for 50 grams. And also, when we did that when we added the mass to it, which made it 100, we also did the same procedure. And we had 70, that's for 70 grams, we had 6.8 seconds in timing. You get it? Now, that is what we did for all these masses. That's for 50, 70, 90, 110, and 130. Thereafter, we found the period for each of them. The period of oscillation, or we call it period of vibration. Okay? Now, the period of oscillation, how do we get it? We divided the time by the number of oscillation, just as we did for the pendulum bulb also. We did that, and then these are the values we got, and then later we squared the period of oscillation, and we got this. Now, from the question, we were asked to plot a graph of t squared, which is the square of the pendulum, to the length of the spring balance. You get what I'm saying? Now, for this time around, that is for the other one, but this time around we did against the mass, the different masses we used. Now, thereafter, we had this wonderful graph sketch here, which you see it's a very perfect graph on a straight line, just that one of the points was out of the line, which is still accommodating. Okay? Now, thereafter, you pick your best line, your best rectangle and triangle, so that we can be able to find your what? Slope. To find your what? Slope. Now, how do you find your slope? Changing t squared against changing what? M. Again, changing what? M. And thereafter, we had these expressions where this point for T2, T against M2, T1 against M1, and then we had this, and this is our slope. So it is still the same procedure. There is nothing different. Both pendulum with simple pendulum with pendulum bulb, or with spring balance, or use a spiral spring, whichever one you use, you are still going to find the center of gravity. It's just for you to bring in the expression here, and then you can get it. Any questions so far?
What are the precautions?
Okay, now the precautions will be attached to the video. By the time we are through, you get the precautions there. Number one precaution, you should ensure that the string is not dragged too much. You see, it is not dragged so much, just drag a little, and then we'll leave it to vibrate. Okay? So see you in our next edition. God bless you.